Section 8.9, graphs of linear inequalities. So, first thing to notice is that we're using inequalities now. We're going to have inequalities, meaning we are either going to get a greater than, a less than, greater than or equal to, or less than or equal to symbols instead of the equal sign that we've had in the past. The good thing is, for the most part, the graphing, the general concept's exactly the same. So before we jump into this here, I just want to remind us about some things we did way back when we were learning how to graph or solve regular equations in inequalities with just one variable, such as negative 2x plus 8 greater than or equal to, how about 32? Okay, so to solve this, notice this is different from what we're doing because this is what we did before. We'll separate these. This only has an x, not an x and a y. So this is one variable equation like we solved back in like chapter 3 and all throughout the year so far. Negative 2x comes down, these cancel. 32 minus 8 is 24. Now I'm going to divide by negative 2, and one rule we want to remember: when you divide by negative, you change your sign. So now it's going to be a less than or equal to. So I'm going to get x less than or equal to negative 12. So there was that one special rule right here. When you multiply or you divide by a negative, you flip the sign, flip the inequality sign. Then from here, what we need to do is we need to go ahead and graph it. So we would graph something like this. We would say negative 13, negative 12, negative 11. It's going to be a closed circle, and we shade it to the left. Okay, so hopefully this is all coming back. We remember doing this. There was this special rule here. There was the circle here. There was the shading here. So there were a few extra features when we went to solve an equation, or a one variable inequality that we had to keep in mind. So when we go to graph inequalities, there's also going to be some special situations that we're going to have to keep in mind. Okay? First things first, linear inequality looks just like this. 2x minus 3y is less than 6. A solution of the system is going to be any ordered pair that proves this to be true. So any ordered pair that satisfies the inequality. Okay, so let's try, I'm just going to abbreviate inequality. Let's try example 1. Tell whether the ordered pair is a solution to this inequality, and they're giving me an ordered pair. So what I'm going to do is I'm going to write it out. 2x minus 3y is less than 6, and I'm going to put my x and my y into the inequality. So 2 times 0, because 0 is my x, minus 3 times 1, because 1 is my y, less than 6. 2 times 0 is 0. I get negative 3 less than 6. Is that true? Yes, it is. So that means that this ordered pair is a solution. Okay? Let's try letter B. Letter B, we have another inequality. So I'm going to start out. I like to write down my inequality so I'm not bouncing back and forth looking up here. X, I'm going to substitute in a 4. So 2 times 4. For y, I'm going to substitute in negative 2, less than 6. 2 times 4 is 8. Now, watch this here because some people get stuck on it. I'm going to go ahead and bring this minus sign down. Now I have 3. I brought the minus sign down. Now I have 3 times negative 2, which is negative 6. 8 minus a negative is plus a positive, so I get 14 less than 6. Is that true? No. So this is not a solution. That means this point does not fall under what that inequality is saying. All right, now let's add to this by going ahead to graph. And like I told you over here, there's going to be some special cases. We're going to see that here as well. First step, it says step 1, graph the line by replacing the inequality sign with an equal sign. So basically that means we're going to place this inequality sign. You can kind of think of it as an equal sign and solve it from there. Okay? If that helps you to think of it as an inequality, as an equal sign, you can do that. Personally, I like to just leave it the way it is, though. Okay, but the idea is that you're going to graph it the same way we've graphed all other linear functions. We find our slope, which in this case is 2 over 1. We find our y-intercept, our b value, which is 4, and we go to plot. I'm going to go up 4, put a point. My slope is 2 over 1, so I'm going to go up 2 over 1. Okay, or as some people have learned, a negative divided by negative is the same thing. So I really could also go down 2, but to the left one, and notice, look, they're going to keep falling on the line. So that works as well, but we'll go from there. So step 1, check. Step 2, use a dashed line for greater than or less than, and then use a solid line for greater than or equal to or less than or equal to. So for if it's just a greater than or a less than, you're going to use a dashed line. If you have that equal to component added in, the greater than or equal to or less than or equal to, that's where you use a solid line. So in this case, I look to see what I have. I have a greater than or equal to, so I'm able to do a solid line. Now that's something a lot of people miss because we're so used to making a solid line all the time that they automatically just say, oh, solid line, but don't forget that fact. All right, so that's step 2. This is kind of like that dotted solid line is comparable to the closed or open circle. So that's kind of where it falls in line. Step 3, we're going to deal with our shading. Just like we shaded here, we're shading here. If the test point is a solution, shade the half plane that contains a point. If not, shade the other half plane. All right, so what we're going to do here is we're going to pick a test point. You can pick any point that does not fall on the line. I'm going to choose 0, 0. 0, 0 is nice because it cancels things out well. So I'm choosing the point 0, 0. So just like we did up here, I'm going to take my inequality, y greater than or equal to 2x plus 4, and I'm going to substitute 0 in for x and y. I get 0 is greater than or equal to 4. Is that true? No, it's not. So that means that the point 0, 0 is not a solution. So this is on the wrong side. That's not a solution, but that really tells us that every point on this other side is a solution. So we can shade all of this and we are done. Okay? So what you do is you pick a test point. If it's not true, you shade the other side. If we would have tested this and it would have been true, that means our test point is part of the solution, so we shade this side. Okay? Let's practice some more. It might take us a little bit of time to get used to, so okie dokes. Moving around a little bit. Okay, graph x plus 2y is greater than 6. So in this inequality, it's not right in slope-intercept form, so I have to get it that way. I'm going to subtract my x's. I get 2y is greater than negative x plus 6. Divide everything by 2. I'm dividing by a positive, so I don't need to flip my sign. I get negative 1/2 x plus 3. My slope is negative 1/2. My b value is 3. So I go up 3, put a point. My slope, I'm going to go down 1 over 2 because my rise is negative 1, my run is 2. Down 1 over 2, so on. All right, that was step 1. Step 2, I'm going to go ahead and either connect it with a dotted or a solid line. Because this is just a greater than, it's going to be a dotted line. So it could look something like that, a dotted line. Step 3, so let's write these over here so we have them on this page. First we graphed, then dotted or solid. Some people like to write that out right when they start. They just say, oops, dotted, just kind of like as a reminder. Or dashed, some people call it dashed, that's fine too. Third step then is our shading. So we have to figure out which side to shade. So again, my point 0, 0 does not fall on the line, so I'm going to test that point. I'm going to substitute 0, 0 into my inequality. I can either substitute into the original or my new one. It doesn't matter because this is the same thing, just written differently. I'm going to put it into my original. I get 0 is greater than 6. That is not true. So that means this side that contains my test point is not a solution. That's not right. And instead I shade that side. Okay? I'm going to